Good morning everyone, I'm Engine Cadet Lavilla. Last meeting, our topic is all about the steam turbines, construction, principles, and operation. And now, we are going to tackle about the two types of steam turbines, which is the impulse turbine and the reaction turbine, with their working principles and arrangement. And now, let's proceed to the course outcomes and learning objectives. For the course outcomes, analyze the construction and operating principles of different configurations of steam turbine systems. So the learning objectives, explain the operating and arrangement of steam turbines in accordance with their operating manuals. What is these the types of turbine? Steam turbines are classified into impulse turbines, where steam expands in nozzle and derives the blades by jet force, and reaction turbines, where steam expands in both fixed and moving blades to create a reactive driving force. So let's proceed to the steam turbine operation and arrangement. First, types of steam turbines. Steam turbines are broadly classified based on the way steam energy is converted into mechanical energy. The two primary types are impulse turbine and reaction turbine. Most modern steam turbines use a combination of both principles for efficiency. Continue to an impulse turbine. Impulse turbines generally layout includes a nozzles to convert pressure into high velocity kinetic energy, a rotor with moving blades or buckets that the fluid strikes, a shaft to which the rotor is mounted, a supporting casing to contain the component, and system of bearings to support the shaft. So the most important is the bearings. Then always the maintenance, or always check the bearings to avoid the vibration and to support the shaft. In a typical water impulse turbine, a penstock delivers water to the nozzles. So as you can see, the picture or the diagram, there's a label named a penstock, which is the comes water from penstock. The water directly flow to the nozzle, so which is the water came from already expanded. So and the spear regulates flow into the bucket shaped runner, which then directs the used water to a tail race. So next, how it works. So which is the operating principles, how it works. Steam is expanded entirely in stationary nozzles before it strike the rotor. So next, the nozzles convert steam's pressure energy into kinetic energy to high velocity of steam. This jet strikes the rotor blades, changing the direction of the flow. So from, as you can see, the nozzle, that's the water comes out from the penstock to nozzle, then directly hit the moving blades or the buckets. So that can change the direction of the steam flow. The change in momentum procedures and impulse force that turns the rotor. No pressure drop occurs across the moving blades, only the velocity changes. So arrangement. Nozzles or a stationary blades. First, extend the steam. Rotor blades, moving blades, or the moving blades redirect steam flow, producing impulse force. Last, often used in quarter stages, compounded impulse turbines for high efficiency at high pressure. Let's proceed to the main parts. Nozzles, rotor with moving blades or buckets, shaft, casing, and bearings. Nozzle converts pressure into high velocity jets. Then jets strike the rotor blades, turn in the shaft. Water turbine example. Water flows from a penstock to the nozzle, and a spear regulates the flow. The bucket-shaped runner captures the jet, then directs used water to the tail race. This is the main parts of the impulse turbine. You can see here the nozzle and casing, runner or the rotor, buckets or blades with water jets, and spear and handwheel and penstock. This is the main parts. So let's proceed to the reaction turbine. A reaction turbine generally layout includes a watertight casing, a spiral volute that guides water to the runner, a ring of wicket gates or fixed guide vanes to control flow and direct it to runner. The runner with its curved moving blades, rarely energy conversion happens, and the drop tube that carries water away while recovering kinetic energy. The picker of fluid acts on the runner, forcing it to turn, and the blade's lap guides the water to exit axially or radially depending on the turbine type. So how it works? Number 1. Steam expansion occurs in both stationary and moving blades. Second, stationary blades act like nozzles and partially expanding steam. Next, moving blades are shaped to function like nozzles themselves, allowing further expansion. This causes a reaction force on the rotor with the Newton's third law of motion. The last, pressure continuously drops across both fixed and moving blades. And the arrangement. Stationary blades expand and direct steam onto the moving blades. Moving blades both expand and redirect steam and to producing a reaction force. Usually requires many stages to efficiently utilize steam energy because pressure drop is gradual. So most required is the reaction turbine because of its pressure drop is gradually. A reaction turbine is a type of turbine where steam expands continuously in both the fixed blades or stators and the moving blades, which is the rotors, with the moving blades acting like nozzles that produces a reactive force which drives the rotor. Here, the pressure drop occurs across both fixed and moving blades. So the layout. Fixed blades or stators direct steam onto the moving blades while allowing partial expansion. Number 2, moving blades or rotors act as nozzles themselves, causing steam to expand further and create reaction force. Casing enclose the systems and maintain steam flow. The shaft connected to the rotor to transmit power output. This is the design and the main parts of the reaction turbine. The same as the impulse turbine, but they have different designs and the other parts with the impulse turbine. They have both different designs and different. The impulse turbine is differ than reaction turbine, because the reaction turbine is the most requires to be designed for the large power plants and large auxiliaries. So the key points: more efficient than impulse type in large power stations or power plants. So reaction turbine is more efficient than impulse type because the reaction turbine is designed as that requires to use in large power plants or power stations or in large auxiliaries. It runs smoothly because pressure falls gradually. So, reaction turbines is more smoothly than impulse turbine because of pressure falls gradually. Reaction turbine is commonly required in modern power generation turbines. So ang reaction turbine is commonly required gamit para sa mga dagko nga modern power generation turbines. Kay naka-design man siya para sa pareham sila nga ang reaction o impulse kay pareha sila naka-design para sa mga auxiliaries, but the reaction turbines is requires nga para sa mga dagko or para itong mga large power plants or power stations and large auxiliaries. The general operating guidelines: first is the startup. Warm the turbine slowly to avoid thermal stress, and admit steam gradually. So dapat kung mag-start ang turbine ato yung ikuan ng gradually or slowly para to avoid thermal stress. Then steam, admit it gradually. Second is for the running, maintain inlet conditions within limits, monitor the speed, bearings, and vibration, and use governing valves to adjust loads. Then last, shut down, reduce load slowly. So kung mag-shutdown ta sa steam turbine, before mag-shutdown, reduce load slowly reduce load slowly. Then shut steam valves. So pawon sa nato ang mga valves in stages, and keep the rotor turning on bearing gear until cooled evenly. So mo totong kan dapat nga di jud kanang di ito pakalitan ng steam turbine. Di na to pwede shutdown kalit, dapat mag-reduce patag load daan, then shut the steam valves in stages, then keep the rotor turning. Kaya di man pwede nga ang rotor ini shutdown, siyempre mag-hinihinip ka na sa kakuan pang, then hantod mo bugnaw na siya ginihinay. Conclusion: steam turbines are broadly classified into impulse and reaction types, each differing in their working principles and energy conversion methods. In impulse turbines, high velocity steam jets strike the blades, converting kinetic energy into mechanical work, while in reaction turbines, both pressure and velocity changes occur across the moving blades. Depending on power requirements, turbines can be arranged in single-stage or multi-stage setups. often combining impulse and reaction principles for efficiency. Overall, the choice of turbine type and arrangement depends on factors like desired output, efficiency, and steam conditions, making them vital component in power generation and industrial applications. That's all for today, and I hope you understand my report. Thank you. All right.